Sound good?
Mhm.
Okay. But Will, when you pull that up on your PC, if it's still not doing it right or you didn't know what to change, let me know again and I'll walk you through it, okay?
Okay. Yep. Okay. Uh, Basically, I was there for some reason. I erased everything, and then I said it just went left. Okay. Well,
Yeah, sometimes it's just best to, well, in that one, just reload the template from the beginning, start over,
Okay.
and then go.
Yeah.
So I have started the recording now. I haven't done much of the grading yet. I've started some things. Most people are done with chapter 1, which is great. Most people are pretty much getting close to finishing 2. Some people starting on 3, which is where we kind of want to be. So I have been getting a lot of questions that I've been answering individually, which is perfect. You guys, you can email me. I got my email on my phone now. You can text me. And if I don't respond, like within a good amount of time, or if I say, okay, I'll text you later, because sometimes if you text me, I'm not home or I'm not working, and then I have to get onto my PC. But I get a lot of texts. In fact, I never delete my texts, so like I can just scroll through and I've got like, these are all the text things I get. I could like scroll for text messages. I don't know why. I got to figure out how to delete everything, but well, I know how to delete everything, but I keep my text messages. Sometimes I do forget to go back. So if you don't hear from me and you're working on your stuff again, send it again. Go ahead and say, hey, remember me. I do have 3 sections of this class, and this class generates a lot of questions. So you're not bugging me. Send it again. I'm happy to help. That's what I'm here for. So I kind of know that most people are still working through some things with chapter 2. But I want to get going on 3 too, because that's where you should be going through. I have posted a couple solutions to things in chapter 2 in the announcements, and those are mostly the questions that I get a lot, like this musical notes program, and then some in the math module. But essentially with the second chapter is we're looking at how we use variables to store data, and then we're looking at not only we learned in chapter 1 what an integer is for a whole number, but we're also going to start using floating point numbers, which are decimal values. So anytime you're working with numbers, things like that, you want to use floats. And then expressions, which is our calculations. So we're looking at how we do a calculation with coding. There's a couple things at the end. Division kind of works differently. A module is a remainder option that's like how to find the remainder of something in programming. And then we have some built-in functions that are in the math header file that we can use. So chapter 2 takes a little bit of time. I can see yeah, about 1/3 of the class is through with the labs, and most people are progressing well through the participation and challenge. So I won't spend that much time on 2. I just want to breeze through some of this real quick. If anyone has a specific question or want to see one of the labs, let me know specifically. So let's see. So I'm going to say this. I'm gonna keep chapter 2 kind of short because a lot of people are through it already or getting through it, which is great, really good. I'm gonna turn off my camera though for a little bit. Stop video. There we are. Yeah, that's just my video. Okay. So variables and assignments, variables store values. There's rules for naming variables. Make sure you read that. Like you can't have spaces. Python, a lot of in this book, they use an underscore between variable names, but you can't start it with a number. It can't start with a special character. Things like that. So the ideal here is we have variable names like X, Y, Z, and then the value that that variable, stores changes throughout our program. So it's not going to be hard coded. And I do get this question a lot in the beginning. People will try to hard code values to their program. So let's look at this first one here. Here's the solution for, this is the first challenge, assigning a sum. So we need, when you write this, it says write a statement that assigns total sum, the sum of nickels and dimes. For example, if the sample output is 100 nickels and 200 dimes, then the output is going to be 300. So what we do with programming is we have our variables, we do some sort of input, we do a calculation, and then we do an output. So remember that 3 steps: input, calculation, output, input, calculation, output. But what we don't want to do with our program is hard code these numbers in our program. We don't want to say, okay, I have 100. I'm going to erase this because I see this sometimes when people are coding it. They will try to change this to say 100. My nickels are 100. My dimes are 200. I can't type there because this one locks it down, but if we can set variables at the beginning, so we could do something like that. But what that does is it makes this program always have 100 nickels and 200 dimes. And then when I print my total and it says print 300, you print 300. But that's not always the case. I don't always have 100 nickels and 200 dimes. I want those values to change. So you don't want to code with specific numbers unless it applies to that program. And most of the time we want the user to enter it because it says input the number. So look for those keywords when you're doing a program. And so the input's coded for us already. It has to be converted to an int too, you guys, because we're doing a calculation. So anytime we do a calculation, don't just do nickel count equals input, dime count equals input, because that will then treat those variables here as strings. And what would happen if I just did input is when I added them 2 together down here in line 8, and then I printed it in line 10, it would print out like 100, 200. It would just concatenate them or join those 2 together. It wouldn't print out as, it wouldn't add them together. It's not going to add 100 plus 200 because they're not numbers, they're strings. So you have to, anytime you're working with numbers, again, don't forget to convert to an integer or a float so that it doesn't treat it as words, it treats it as numbers. And then when I go to 200 or 100 plus 200, it would print out 300. So that's what you're going to do here. These are just samples. Sample output is 100, 200, 300. I could put, okay, I'm going to run this program. Notice it doesn't have, I don't have any place to put input. So what happens in this case is Zybook supplies the input for us. So if there's an input box, I could put in 100, 200, or 9 and 0, or 3040. I could put in whatever values were different, but in this case, Zybooks is supplying the input to test our program. So all you had to code in this one is just that statement. Then my output is correct, and I can then submit it. Same thing here, write a program that assigns cell count with cell count multiplied by 10. Multiplication, the asterisk performs multiplication. So as an example, if the input is 10, the output should be 100. So cell count is already coded for us. We convert it to an int because it's a number. We're going to just take cell count, and that's going to be equal to cell count times 10. There's no input box, so let's let Zybook supply the input. They'll test it with 10, they'll test it with 420. That's gotta be, I can't imagine. Sorry, I just think programmers, you know, they're all sitting there, let's put 420 in there. Ha ha ha. You know, I'm right. But anyway, so there we go. So just you know, another example of how Zybooks works. So that's the very beginning of chapter 2, how to work with variables, how to do inputs. Let me get back up to here. I'm not going to go through all of that, but that's the starting part. Identifiers. Oh, that's rules for identifying variables. Nothing great. I mean, read through that and do through that, but okay. Floating point values. This is big in programming. When we deal with numbers, we have whole numbers, which is an int. We have floating or double, it's also called sometimes. Floats are decimal values. So anytime you're dealing with money, make it a float. Anytime you want to potentially have a fraction, a decimal, then you have to include that in your program. So miles equals float input, enter distance in miles. Because I could walk 3.5 miles or 450.3. I could walk a half a mile, and I want credit for every single mile I walk. So it's not just an integer, it's a decimal. Hours to fly is going to be miles divided by 500. 0.0, we do that 0.0 so we can get a decimal in our output. Hours to drive is 60 miles. 60 miles to basically we take in how many the distance we want to go. It's for every hour it's 500 miles for every to fly, and for every hour it's 60 miles to drive. So that just calculates it for us. Some things on scientific scientific notation. Here, this is how we format a floating point value. So you can change this. This is the syntax. Use print, parentheses, F, single quote. This is your variable name, then a colon, and then dot 2F. 2 means 2, the dot 2F means 2 to the right of the decimal. You want to format this variable called my float to 2 decimal spaces. If you wanted it to go to 6 decimal spaces, then do 0.6F. Or if you, like down here, you wanted it to go to, if you wanted it to show 3.1416, and that's 4, then do 0.4F. 4. So that's how you round a number to a specific decimal value. Otherwise, it'll go out as long as the number is there, it'll go out far. So, like, here's the default output for pi. Like if we just said math.pi, we're going to get 3.1459265 3589793. That's this first statement here. But if I want to round it to 4 decimal places, then I just take math.pi, which is my variable name. Well, I'm using the math header file, but I then say .4f, and I now have something that's more manageable. So read this paragraph, manipulating floating point output, read it a couple times. That's how you round to a specific spaces. I do think I went over this one. I think I gave you this one, or I've gone through it a couple times. Well, I'll show you right there. It's just you're calculating how many, you got to figure out how many gallons of paint you need. I might not have given it to you, to be honest with you. I share solutions with some people, so I might have just helped a couple people on this, or I might have posted it. I don't remember, but you guys know. But this one, it says do not format the output. So I don't need to do that float thing at all. I just need to calculate it. And I take it in as a float, which is hard coded for me, so I can't mess that up. I have to take it in as a float. So as wall area could be 450.5. It could be 100, and it could be anything with a decimal, or it could be a whole number. But let's see what happens here when I say, okay, gallons is equal to square feet divided by 350.0. That's exactly what I coded. When I run my program, it seems like it's a while to run that. Here's my, if my input is 250, here's my output. If my input is 578.6, here's my output. You guys don't have the luxury of seeing the solution like I do. Sorry. Your solution goes here. That would work too. Not putting that 0.0 there. And that's because I've taken it in as a float. So this is already a float. I just wanted to check that. Expressions, addition. This is just reminders of how addition, subtraction, multiplication, exponent. We can use the math.pow header file, which you do in some of the labs that you code, or the asterisk is like x to the power of y. You could also use that. You could use math.pow and then say x comma y. But you can't use the caret. You can't use that button that's on the number 6 on your keyboard. That's the caret. It looks like a TP.
Yeah.
You can't use that. The division operator is normal. Remember the order of operations. Remember the what happens first. So if you are combining operators, put parentheses around whatever you want to happen first, and then it does multiplication, division, addition, and subtraction happen last. So you will get the wrong output if you don't remember the order of operations properly. Python expressions. Oh, I get this question sometimes. A good practice is to include a single space around operators for readability. So if you're coding, what that's saying, let's see, what's that saying? What that is saying you could do A space equals space B space plus C space, like that. But that's the same as A equals B plus C. You don't need to put spaces on either side of the operators. It's just suggesting that this is easier to read, and it is when you have a long formula, but it's not needed in any programming language. You could have you could have a space there or no space there. It doesn't matter. Doesn't matter at all. I point that out because I get that question a little bit. I get that question sometimes. Compound operators, you can read about them. I'll tell you right now, if it confuses you, don't worry about it. You don't need to use them. But it's just combining operators to kind of shorten up your code. It's a shorthand, you know. This is a good program here. I'm not gonna show a solution, but here's some hints to it. Our input's already coded for us. Our output's already coded for us. So we have one thing we need to code. We're gonna write a single statement that assigns average sales AVG underscore sales equal to the number, to the average of the number of sales. So it doesn't tell you how to calculate average. Something you should know from math. To find out the average, we add 1, 2, 3 together, and then we divide it by the number of values we have. So in this case, that's 3. So your calculation is going to be your average sales equals this sales plus this sales plus this sales divided by 3. But the important thing here is to use parentheses around what you want to happen first. And then the divide by 3 is going to be at the end. So number of sales plus number of sales 1, 2, and 3. When you add those 3 together, you have to put parentheses around them before you divide it by 3, because that's how you find the average. And then line 10 prints that out to the screen, converts it to 2 decimal places. So we get something like $5 or $48.52, and not something wacky. We round it to 2. This is one example here where So with programming, it might be intimidating if you're not good with math. This is one example where you have to know how to calculate average, and it might be something that you have to look up. Sometimes that's the case for some things with programming, with especially learning programming, and it's not always going to tell you how to do it. It might be something that they just expect you to know already. So keep that in mind. If it's something that you don't know and you can't find out with a little bit of Google research, then ask me and I'll help you with it. Like, you might come across a program later on that says, given these sides, calculate the area of a triangle. But it doesn't tell you how to calculate the area of a triangle. First thing I do is I go to Google. How do you calculate the area of a triangle? And that's what you would code then. Okay. Just a little heads up on what we're doing here. Now this one, I do think I gave you, I think I shared this with you already, but I'll share it with you again. This is another example. Given the sphere radius and pi, we're going to compute the volume of the sphere and assign it with the volume. Assign the sphere volume with the volume. I don't know how to do that, but this one, they assume we don't. So they say, okay, the volume of the sphere is 4 divided by 3 times pi times radius raised to the 3rd power, or radius times 3. So it does give us the formula, but it gives it to us in English words, not in programming words. So if the input is 1, my output is here, and that's because I am taking 4 divided by 3, and I'm multiplying it by pi, 3.14, or math.pi, and then I'm multiplying that times the radius 3 times. So times 1 times 1 times 1. So how do we code that? Pi is put in here automatic. Pi is put in here. I could use math.pi, but we haven't hit that yet. So we're just going to code pi as 3.14159. Sphere volume is 0 because we're just resetting it. Sphere radius is an input. So if my input is 1.0, this is my output. If my input is 15.7, my output's going to be different. So I'm going to calculate this. I'm going to put my calculation here based on what they're telling me there. And then my volume is displayed and it's rounded to 2 decimal places, but that's already coded for you.
I have a question. So when I tried to put my 1.0 into number 4, this sphere's radius, it goes into green. 4, 5, and 6, they go into, oh, I'm sorry, 5, 6, 7, they go into the color green. Unless maybe I'm not doing it.
When you type, what were you trying to do? Something like that?
Yep.
Yeah, because okay, any number comes up in green, any variables in black.
I'm sorry, the number 4, number 5, 6, and 7, that little block.
Yeah.
To the left of it comes in up in a letter green, a color green, I'm sorry.
Yeah, you can't, yeah, you can, that just means that those are the only boxes that you can type in. You can't type up here.
Oh, I see.
Because this is already hard coded for us.
Mm-hmm.
Because it's correct. They don't want you to mess around and mess up the parts of the program that are working for you. They only want you to type in the area. I mean, I can put a bunch of spaces and type there. They only want you to type in the area that to code the formula. So they only want you to type here. But all this other gray stuff, You
Mhm.
can't type in, you can only type,
Okay,
you can't type, and if you try to type up there, it'll say, it won't do anything.
exactly. Okay.
So that's the only place you can type. So here, the formula is gonna be here, and when it gives us the formula, how that, let's put it out this way, how that, and there's, you could turn these around, but here's the formula for this one. It says volume of sphere equals this. So here I have sphere volume equals. Now, this one says 4 divided by 3. That could go at the beginning because we're just multiplying that times pi times sphere radius raised to the power of 3. So you could do it. Actually, let me just turn it around that way just to show you. Because then it's just like how they have it. It says 4.0 or 4 divided by 3, and notice that's around parentheses.
Mhm.
So I put parentheses around it. And then right when you look at a formula where something is right up next to the thing, in math, that means multiply.
Yeah.
So we say times pi, and pi's up here in line 1 is a variable, times, which is, so times pi times r raised to the power 3. And what that is my radius raised to the power 3. Here, I'm just going to do radius times radius times radius. What you'll learn farther in this chapter is how to do that differently by using some built-in functions. But let's just keep it like they say. So that's how I converted this statement into line 7 of code. Let me run it. If my input is 1, here's my output. If my input is 5.5, here's my output. So depending on whatever the input is, it calculates a different output. So there are things that are math related. We do that with coding. We calculate things a lot of times with it. Sometimes it'll give you how to calculate something, like in this problem. The problem before, it didn't tell us. You might have to look it up. And then always remember there's, use parentheses around what you want to happen first. There's more than one way to code something. You could have coded this one differently, as long as you're doing it in the proper order. 3 divided by 4 times pi times r3. Does anyone have any questions? I don't see anything in the chat, so I assume we're good. I'm just going to keep going. I mean, Will's asking, thank you, Will, but if anyone else has any questions, I know there's about 6 people or 5 people in here. Okay, the next challenge is, I'm not going to code this for you because it's the same thing. It gives you the calculation, and it has some things that are hard coded for us. So we can't type up here. We can only type down here. And G is assigned a value.
Yeah.
M is assigned a value. Gravity is assigned a value because that's what we're trying to calculate. Acceleration of gravity. And we're doing one input, which is distance to the center, which is represented as D2. So here's my formula right here. So what I'm trying to calculate is the acceleration of gravity to the center of the earth. So you just say excel underscore gravity equals this. But using the proper order and parentheses around what you want to happen first. G plus M, multiply those first, so put parentheses around it. Divided by parentheses D2, so maybe take distance center times distance center. Since we haven't looked at the POW function yet. And then that's all you do. It's one line of code. There's the formula for you.
Let's try to run it.
You want me to run it?
Yeah.
I didn't code it, but I can code it. I was trying not to do that one for you, but since you asked me for it, I'll do it.
Yeah. This mud stuff is a little bit complicated.
Yeah, I understand that because it's intimidating. Math can be intimidating. So, but I mean, everything is in there. It's just kind of like break it down. My formula or my variables are capital G and capital M. So I'm gonna keep those the same because that's based on how they're defined there. And then I want to divide it by distance raised to the power of 2, but I'm just going to do distance. Well, I'll put parentheses around this too, but it's not needed, but distance center times, since I haven't learned the POW function yet, I'm just going to do this. There you go. And then I print out the gravity, but I round it. So let me run it. I could put parentheses around the whole thing. Again, Zybook supplies an input for me. My program calculates the output.
Thank you.
You're welcome. Now, if like lines 1 and 2 weren't there for us, we could have used those numbers specifically. We could have said Excel gravity equals 6.673 E minus 11 divided by 5.98 E 24. Divided by distance times distance, but that just gets really messy. So we took those values and put them in here in those variable names. Division and module operators. This is how we use division and mod operators. There's a regular division symbol, which is the /. There's 2 /, which is the floor division operator. That one's used to round down the results of a floating point division to the closest smaller whole number value. So here's some examples. 20 floor 10 is 2. 50 floor 50 is 1. It basically tosses the remainder and rounds it down to a whole number. So that's the double equals, or the double /. There's the regular division, the floor division. This shows you a couple examples. What would you get? See, what's 5 divided by 2 is 2.5. But not when we use the floor operator. It rounds it down. So that's so wrong because we're using the floor division and not regular division. So 5.0 divided by 2, floor divided by 2 is just 2.0. The mod operator, it's called, you can call it the mod operator, modulo, or mod operator for short. This calculates the remainder of something. So 24 mod 10. If you did 24 percentage sign, that's the operator. Your answer is, if you were to take 24 divided by 10, that's 2.4, right?
Mhm.
Because 10 goes into 24 2 times, then we have 4 left over.
Mhm.
So what this operator does is it doesn't care about the whole part of it. It just cares about the decimal part. So 24 mod 10 is 4. Doesn't care about what's left. Oh, it doesn't care about the whole part. 50 mod 50 is 0. I don't use mod operator a lot. There's times when you don't, you do just want what's left over. And so here's one. 78 divided, or mod operator 10. 70, if you did 78 divided by 10, that will be 7.8. So in this example, your solution is 8 because it's what's left over. Compute change. Let's look at the solution because the mod operator can be confusing as well, but it's coded for us already. So if what we're doing with this one is a cashier distributes the change using the maximum number of $5 bills. So we have, so say we have $35 or $37 in change. It's going to figure out how it's going to take that amount to change and then module divided by 5. So it's going to figure out how many times can I, how many $5 bills can I get out of $37? In that case, it's 7. Because 7 times 5 is 35, and then I have $2 left. So if I put $37 to change, I think if I can't bring up my calculator because I don't have that screen shared, but you know, 37, it basically take 37 divided by 5, that's 7 with 2 left over. So what your oh no, that did the floor. So we did the floor first, and then the module operator is the 2, so left over. So we could figure out both parts of that using those operators. Let's look at a solution for that. So number of 5s, we use the floor to find the whole part of it. And then to find out the number of 1s, we use the mod to find out what's left. and then my output is coded for me. So floor division looks at the whole number, discards the remainder. The module operator just looks at the left, what's left of it. So again, $37 and change. If we want to pull out, we want to figure out how many $5 bills we can get out of that. We use the floor operator, so we get 7. Then we use the mod operator to look at the other half of that, which is 2. And half of this is already coded for us. Most of it's already coded for us, but the part that's left is how many $1 bills do we have? So we use the module operator for that. The floor part of it will do the whole part. Any questions?
Give it a try.
Give it a try.
Mhm.
I did put this in the announcements yesterday, so I'm gonna leave that, I'm gonna leave this here. So we can go on with some parts of chapter 3. Chapter 3 is long, so I don't want to spend forever, and I know some of you are still finishing up 2, so I don't want to go through all of 3 quite yet, but we'll Zoom again next week. There is something called the math header file in every programming language. Math header file is a built-in part of the code that we include into our code so that we don't have to reinvent the wheel. We don't have to recode things that already exist. Like, I don't need to recode how to how to find the square root of something, because it's the same thing. So I just include the math header file and then I call the square root function. To do that, at the beginning of your code, you say import and then the header file that you want to add or use. So here I want to import math. And that says, okay, now you can use all of the functions, all of the features that are in the math header file. They're called header files, but modules. Here's some of the examples of things that are in the math header file, math module. And that's the same in almost every language. So it doesn't matter if we're learning Python or JavaScript or C#. They all have header files. They all have a math header file. And then they all can do most of these things in here. And then maybe some do more. You can always call ceil. You can always find the factorial. You can find the exponent or raise something to a power. Like back in that one program where it said d raised to the power of 2, I could have used this function. And I could have said, you know, my answer equals pow parenthesis d comma 2 and then parenthesis, and that would have been the same as d raised to the power of 2 or whatever that one where it said something raised to the power of 3. I forgot the example, but it could have been number comma 3, because that would have been the number raised to the power of 3. So here's the whole list with Python anyway of the functions that are in the math module. And then there's a couple examples on how to use them. You'll be using them in some of your programs. Square root's another common one. I gave you the solution to 2.9.3 yesterday. Because this again is a long calculation. And it's doing the square root. And it's raising x2 minus x1 raised to the power of 2. So you're using square root and pow in this formula. So it does give you the formula here. It does give you the answer in the question. But what's hard is how do you translate this English explanation to Python explanation? So look at the example I posted to find a solution for that. And I think that's really it for this chapter, for chapter 2. 2.10 and text isn't really important. It's kind of just a fun way to look at how numbers are manipulated though. So I'm not going to go through any of these labs. I think I've included some. I've already gone through some of them. So individually give them a try. If you have any questions, reach out to me and I'll help you individually on how to do these labs that are assigned. Everybody good?
For now.
Okay. Give it a try. If you don't have my cell phone programmed in your phone yet, do that. It's 616-644-9045. A lot of times I have my computer nearby and can just look things up to respond to you. Always this general information, always tell me what lab number you're working on, what lab you need help with. So I know. I don't necessarily need to know what class you're in. I can tell it's programming if we're using Zybooks, but tell me what lab you're working on so I can get to it easily. Okay, less people have started chapter. This is good for me to see. I can see less people have started chapter 3. Only 20% are even through the participation. So let's take a look at some of the basics of this. Just make sure my recording is still going fine. Looks good. Okay, chapter 3 is some basics on strings and sets, lists and tuples. So these are different ways to work with variables that store that can store letters. So a string. So a string is any sequence of characters like Mary. And it can be stored in a variable. So you could have a variable like first name, maybe a variable named first name. And then you can set it equal to Mary. And it is different than like how you work with numbers because numbers don't have quotes around them. So know that you know, how you do assignment statements when you're working with strings and when you're working with integers or floats. String, everything in Python is a string by default though. So if I said number 1 equals input, and they put in they could either put in a word in there, they could put a number in there, because everything by default is treated as a string. Programmers create string literals by surrounding text with double or single quotes, like Mary or double quote Mary. I always use double quotes because the single quote could sometimes comment or end the statement, because single quotes are used in other places within the code. So I just always use double quotes. It's not necessary. All right, let's see some of the problems or questions I get asked a lot. Reading multiple data types. Person name plus 5. Okay. We need to type 2 statements. That's it. The first one reads username into a person name variable. So person underscore name equals input. And sometimes, okay, it says do not write a prompt for the input values. So a prompt means like this: enter their name. That's a prompt. But this one happens to say, don't write a prompt. We don't want you to write a prompt. Just say variable name equals input. So that's what I'm going to do. So I'll take that out of there, not use a prompt. So I'll just say person name equals input. Person name is a string, right? Amy, Katie, Julie, Jennifer, those are all strings. So I just do input. I don't convert it to an int. The second read reads the username person name as an int or integer. So I think if I said person's name, I meant person's age. So I'm going to take in person's age. And I'm going to do the input convert to int. So then I can take in a number. And then my calculation is done here within the print statement. It doesn't have to be that way. You could have done it up here and stored it into a different variable name, but we can't modify this. So all we need to do is just, that's it, because the adding 5 to it is there. This is just showing you the difference between ints and input int. Do I have that backwards? Because I often do that. Int inputs. I did. See, I make errors too. I had input int. Switch it around, convert my input to an integer, And now I have the correct answer. So pay attention when we're working with different data types. What's a number? Convert it to an int or float. What's a string? You just do input for. Concatenating string means joining them together. You're just writing 2 lines of code here, one that reads the value for my city followed by my state. Do not provide a prompt, so just my city equals input, my state equals input. Assign log entry with the current time, my city and my state. So we have current time hard coded right there. So once we take in my city, my state, then we're going to put that into, we'll take in my city, my state, and then we'll put log entry equals concatenating. We're going to join those 3 strings together. But they're not, none of them are converted to integers. So you're not adding them, you're joining them, you're concatenating them. Let me show you this one because I do get questions on here. So we take in my city, my state, current time's already hard coded up there. Log entry equals, we want to get this to be the output here as an example, but Houston and Texas, those are in variables, so we just leave them as inputs. Then log entry equals current time plus my city plus my state. But the big difference here with these pluses is these are not numbers, so they're not adding them at all. They're concatenating them. They're joining 2 strings side by side. That's it. And I need to have spaces. I need to have this space here, this space here. So I say plus single quote, space, single quote, plus single quote. There's a space in there, single quote. And what that does is it puts the space between city and state. It puts that space here. It puts that space here. This space is hard coded right here. Any questions on that? This one again has no input box for my city and my state. We're going to let Zybooks supply it. So I just hit run and let Zybooks put in a couple examples. There's Houston, there's Santa Barbara. Big difference between using the plus sign for addition with integers or floats, or using the plus sign with strings, which would then just joins them side by side or concatenates. It's called concatenate. Okay, this starts to get a little complicated. I don't know how far you guys are. Is anyone in this room here right now? Are you guys on to using lists and tuples yet?
Yeah, I am.
Okay, who said that?
Sorry, Matt.
Okay, Matt. I'm gonna start this section then. But not get too far so people have time to, so people start it on their own and then I'll come back to it. But if you want to go in a little bit more deep, then let me know right now what one you want to see, but I'll start it here, okay? Okay, so we have a couple. We have a couple different types of ways to store strings and groups of data together. So we have a container, we have a list. Those are in other places, sometimes other languages, they're just like arrays. So a container is a construct used to group related values together and contains references to other objects of data instead of data. A list is a container that's created, and then we use brackets. Let's see, what is that? Where does that say there? I'm just curious. Oh, geez. Then, so we create the list like my list, and we set it equal to different values. And these are a little bit different than arrays, because arrays have to have the same type of data, like it all has to be numbers. But a list can contain different data types. So here would be 10, which would be a number, and then here's ABC, which is a string, and it's not just one variable, it can store a string of things, multiple things. Everything that's inside this list is called an element, and they're referenced by something called an index. So if I have a list that's 10 things long, my index number would reference which one I want. So if I said index 1, if I said index 0, that would be this one. If I said index 1, it would be this one. If I said index 5, it would be the sixth one, because when we work with arrays or we work with lists in any programming language, the index starts at 0. So that means we start counting 0, 1, 2, 3, 4, 5, 6, 7. And that would be 8 places total, because 0, we start counting at 0. Here's another example. Prices equals 20, $14.99, and 5. That is a list of 3 values. It's a list that's 3 in size, but we don't have an index number 3. We have index number 0, which stores $20, index number 1, which stores $14.99, and index number 2 that stores 5. Very, very important, because we can reference list names individually by their index. So 0, 1, and 2, and that's where those numbers are stored. It's not index 1, 2, and 3. Remember, counting in programming arrays and actually anything, counting actually starts at 0 and not 1. So don't forget that. Want to try it out? We can create we created a list of names: Daniel, Roxanne, Roxana, and Jean, and then we just print names. That's an easy way how to print those 3 names together. How this saves time is, instead of creating, you don't have to create multiple variables. You don't have to create a variable for name for user 1, name for user 2, name for user 3, name for name for all of my students. I could just put my class list equals, and then assign the 30 names once, and then I could print that class list all together. I could print who's ever in the 4th spot. You can specify, can I type in here? You can specify which block do I want to print. So if I said names in the 1 spot, it would print 0, 1. It would put Roxana. See, I put 1 and I print Roxana because that just says go to that 1 index. Go to the 2 index, it'll just print Jean. But if you don't specify an index, it'll print the whole list of things.
Hello,
Hi, Owen.
you're looking for the car that's parked on the road.
Is someone in our driveway? Okay. Sorry, guys. There's a giant truck blocking our driveway. Weird. What did he do? That's a list. Lists are very helpful. They're very useful when you're storing data. And working with it, because it cuts down on the variable names. I think that big truck that's blocking the driveway is probably what I hear pounding and stuff. I live in townhouse, so there's other activity going about. Adding things to a list, you can use pop or remove. There's different ways to manipulate that list. You can use append, pop, remove. So here's a couple examples. If your list was called list, so my list dot append and put a value, like ABC, it would append ABC to the back of that list, to the last spot. So then, you know, if it was the list with the names, it'd be whatever the first name was, then Roxana, then Jean, then ABC. So we're adding on 1 to it. List.pop removes the element at the index that you supply. So list.pop and then parentheses 0 would remove the very beginning one at index 0. Does someone have a question? Okay, list.remove and then V removes the first element whose value is V. So it looks at dot remove looks at the value that those variables store, not the index. So you could either do it by index or the value that it stores. Some examples of how to use the list to just print my list, or how to do the append module like that. And then how to use the pop module and the remove module. Here's a list of other things you can use with lists. You can find the length of a list. You can find the smallest value of the list, the largest value of the list. You could sum up a list if it's numbers only. So if you're working only with numbers, you could do sum list and like total equals sum list in parentheses, and it would go through every element of that list and add it up and put it into the sum. That's a helpful list. That's a helpful table to know. 3.2.1. That's list. Tuples. Tuple. A tuple, pronounced tuple or tuple, is similar to a list, but it's an immutable, which means once it's created, it can't be changed. So a list, we could add to it. We could pop, we could delete, we could do whatever. But a tuple, you cannot change. A tuple is also a sequence type. So you could find out the length of the tuple. You could individually index a value of it, but you couldn't change it. So if White House is a tuple, you can never change the coordinates. You can never change the length. Here's an example. White House coordinates equals this and this. Then I print them out. And then here I try to change them. And it gives me an error because it's a tuple. You can't change the tuple. So once the values are set in the beginning, this is how you define it, then you can't change it. And notice we're using parentheses around that to define that tuple. In our list, when we define it, we're using hard brackets. And then also it could contain different values. So I could put a number. A number there and print those three things. So, you know, the list, you have brackets. The tuple, you had parentheses. So make note of that. And remember, once it's set, once the tuple's set, you can't change it. So I could change the list of names, but I can't change the tuple of the White House coordinates. Those always stay the same. Oh my gosh, that scared the crap out of me. Somebody, I don't know, Will, if that's your mic that's not muted, but somebody screamed in the background.
Yeah, not mine.
Oh, somebody else's
Yeah.
then.
Yeah.
Name tuples. I think this is getting a little bit in depth. Let me show you one example here. And then I think I'll end until people have a chance to look at this a little bit more. It says, this is how we define a named tuple. It says define a named tuple that describes an athlete on a sports team that includes name, number, position, and team. Now, one of the things that I hope you can see is, even just from earlier, is that if we wanted to store name, number, position, and team without having things like lists and tuples, we would have to create multiple variables in order to do that. The ideal of a tuple or a list is that it's one variable name that stores these things. So I'm going to use a name tuple in a collection, and then I create this name tuple, which allows me to store different types of values, a number and a string. And then this is how I define it. The rest of it's hard coded for us. And then it's just printing, it's printing each of those elements, different elements of whatever was assigned. So here's name tuple 1 Cam, 1 named LeBron, and these are the values that are in this player tuple, So Cam.name, LeBron.name will print would print this. And then LeBron.number would print this. LeBron.position would print this. And .team would print this. So that's how you access each of these values that are inside this name tuple. I think I'm going to stop there because we'll come back. So I went through 3.3. Let me just make note of that. I don't think a lot of other people, even that are watching the video, are going to have gotten this far. And plus we've been going for about an hour and a half now. So no one likes to watch that long of a video. Oh my gosh. Scared me. But there's dictionaries too. There's a lot of ways to store different values. So they're very convenient, but that's what chapter 3 is about. Formatting, yeah. Only 8% have started the labs yet. So Matt, did you have a specific question about 3 or not yet, or you're good? All right, guys, I'm gonna stop from now. I think I answered anybody who had questions that they sent to me. I think I got that answered, but if not, just reach out. I hope that helps you with chapter 2 and helps you get started on chapter 3. And then either the end of next week, sometime probably Thursday, or the beginning of the following week, I'll come back on again and finish up 3, maybe start 4. But I'm paying attention to where you guys are and where I'm getting questions from. So that's kind of where you should be in the classwork. Finish 2 up as soon as you can. Get moving on 3 is a good spot. Branching and loops, those are a lot longer chapters. And then we just do functions after that. But branches and loops, those are a lot longer. So I want to give you enough time. So get through chapter 2 and 3 fairly soon. By the way, if you're watching this later, I'm talking on Thursday, September 29th. Just to kind of give you a gauge of where I said you should be. All right, anyone else? No other questions? I don't hear any. So I'm going to let you go for now. Thank you for watching and listening and coming. And I look forward to meeting you guys again. If anyone wants an individual Zoom, let me know. We can do that too.
Oh, thank you.
Yeah, bye.
Bye.